problem is human-caused contamination. And the contamination can come from agricultural waste. Those could be pesticides, right? Fertilizers can be bad as well. Industrial waste like toxins, dioxins. One of the main problems with industrial waste are the synthetic organic compounds, because they kind of trick nature, and nature doesn't really know how to deal with those. Landfill and septic tank effluents, right? Those could have bacteria and viruses. Petroleum products, acid mine waste. So all these are examples of human-caused contamination. One of the things with the contaminant is that groundwater transports pollutants away from the source of input and creates a contaminant plume. And that plume will always have a higher concentration near the source and will decrease as you go farther away. And so the plume opens up in this plume head. And that's what this diagram is showing here. Now, how do you clean this up? Well, one of the best ways to prevent contamination is to prevent the products from entering the groundwater in the first place. But obviously, lack of regulation has allowed us to contaminate this groundwater. So especially around gas stations, if we go back to this diagram here, we see all those gas stations, those tanks eventually leak, and that gets into the groundwater. So at a local source like a gas station, and you've probably seen this, is you basically exhume all that dirt out. You probably want to put it on top of a clay layer, because clay absorbs some of the chemicals, and remember, clay acts as an impermeable aquitard, not allowing any more chemicals to go deeper into the subsurface. But you dig up all that soil, all that dirt, and you let it sit there in the air to aerate it, and eventually will clean up, right? But other things that you can do, you can inject steam, right? And the steam will force some of this contaminant to a central area where you can remove it by pumping the wells, right? So groundwater contamination can be cleaned up by utilizing engineering principles and natural processes. So this would be like an engineering principle here. It could be, but it is expensive. And most remedial strategies include removal of the source. So that's like this here. You remove the source and let it air out. You could also use bioremediation, which bacteria can attach themselves to some of these chemical compounds and break them up. And then also clay absorbs some of those chemicals. Now, another major problem with groundwater is a depletion of groundwater and lowering of the water table. So we know here in California for the last really 5 years, we've had a severe drought. And this is from 2013 to 2014, showing some of the areas of greatest decrease in the water table, right? So this is just in a 1 year period, how much the water table has decreased. And you can see in the southern San Joaquin Valley of California, we're seeing over 10 feet of decrease of the water table in just 1 year, because farmers are just desperate. One of the problems here is well, obviously it's a breadbasket, and farming, agriculture, it provides food for the nation, so they need the water there. But maybe the techniques of how they do it need to be investigated there. And then the other problem you see up here in the Sacramento Valley, there's a few areas where there's excessive groundwater water table drop here. And then our Santa Clara Valley, right? We got a lot of people living here. We're seeing quite a bit of drop in here. And then India is also experiencing a similar problem as well. Now, this is in 2014, 2015, these images came out showing how groundwater has changed in really the past 12 years. And it's from the GRACE satellite, which in 2002, one of the first images it took, what it does, it measures gravity and magnetism of Earth, and that can be affected by how much water is in the subsurface. And you can see that over time, we really decreased this water table. Now, the last section of this chapter deals with karst, and karst refers to an area that's underlain by carbonate rock, and carbonate rock includes limestone. Remember, limestone is a rock composed of calcium carbonate, which is calcite, but also metamorphic rock like marble. Marble is also composed of calcite. It can develop these karst topographies as well. And then there's also dolomite or dolostone. And what happens is in the subsurface, water will mix with carbon dioxide, either picking up from minerals or clays or just from the atmosphere as CO2 mixes with water. And it produces this carbonic acid, H2CO3. And carbonic acid, we all know what happens when we put acid on calcite, right? That's one of the tests we did. It begins to fizz or dissolve, right? So over time, this weak acid, carbonic acid, will dissolve the limestone, the carbonate rock, making these caves, these caverns. Although 5% of the caverns investigated or cave systems are caused by sulfuric acid, which is a different mechanism, probably from volcanic gases, the sulfur gases. And the Carlsbad Caverns in New Mexico were formed by this sulfuric acid. Now, let's look at limestone. So one thing about limestones or carbonate rocks, it's heavily jointed. And usually these joints occur in orthogonal or 90-degree angles. And so the water seeps in there, bringing down the CO2, mixing with the water, and starts dissolving weak layers. And normally they occur in these horizontal cave systems, right? Different levels of cave systems. Then because we have these caverns, when water does seep into the ground, when the water seeps into the ground, it's going to open up to this cavern and make these structures called speleothems. So speleothems are either going to be flowstone, these are flowstones, which occur on the walls of the cave, or you can have material that hangs from the ceiling wall here. That would be a stalactite, or it could grow from the floor to be a stalagmite. So those are also speleothems. And then if a stalactite and a stalagmite merge, then we got a column. So you can think of a stalactite as hanging on tight, whereas a stalagmite might reach the ceiling. That's one way I differentiate them. But initially these stalactites start off as these soda straws, which actually are hollow, but over time they fill in and become stalactites. This picture doesn't show it, but the smaller stalactites are really called dripstones. So that's our speleothems. And also the other thing I should point out here is because when this groundwater enters the cave, it enters an airspace, it loses a little bit of carbon dioxide. And that loss of carbon dioxide causes calcium carbonate to precipitate, and you start growing these speleothems over time. So the evaporation of CO2 allows the precipitation of calcite, enabling these stalactites to grow over time. Now, Karst, your book talks about this area in Slovenia called Kar, and so which is covered by these limestones, and that's where we get this word Karst topography, and it's characterized by sinkholes, right? We have these sinkholes. Obviously, we have the carbonate rock. We have disappearing streams. We have these solution valleys, these natural bridges over here, natural bridges. So an interconnecting series of sinkholes, if you can connect them all up, they would make a solution valley. So here's a little valley. So these are probably all sinkholes that are now connected, and so they make a solution valley. And obviously we'll have the caverns here. There could be underground flowing rivers as well, and when they come out to the surface, they become springs. Now, here is a good example of some karst topography. Here, these are actually called tower karst. So this is actually a pretty well evolved karst topography here. And then here's an example of one of those disappearing streams. It just goes into the subsurface. Now, in China, there's a good picture of those karst towers here, or tower karst. Yeah. Let's see how this landscape develops. So there's been some argument as to how the limestone caverns form, the carbonate caverns form. But one thing, they have to form under the water table. And more specifically, it's probably right beneath the water table, because this is where the fresh CO2 is entering. Here's where you're probably seeing the highest concentration of carbonic acid. And also it'll help explain is that when spelunkers and geologists are going down there investigating these caverns, we always find them in these horizontal bands, which suggests that they are forming directly under the water table. So they are forming under the water table. So when you go into a cave, one piece of information you get out of it is the climate has gotten drier and the water table has subsided. It used to be higher in the past. In this diagram here, we're going through time here, and we're seeing caves forming just below the water table, right? From carbonic acid, and a few cases that's sulfuric acid. Then over time, the water table drops, water table sinks, new caves form deeper down, and the old cave system is now exposed to air, right? So old caves in the Speleothems start growing them, so the stalactites and the stalagmites. And then here, what we're seeing, we start seeing the collapse. So as soon as we start forming, dropping the water table, we get these caverns or these empty spaces, and that starts creating the sinkholes, right? So when you start seeing sinkholes and the Karst topography, we have an older landscape. The landscape is more evolved. If we have a carbonate landscape with few to no sinkholes, it's considered a relatively young landscape. But over time, it will turn into one of these older landscapes. Now, looking at this diagram here, the chapter starts off with a woman in Florida waking up in the morning and looking in her backyard and finding that her 200-year-old sycamore tree has disappeared. It's just gone. Well, what happens? A sinkhole formed in her backyard, and it pirated the water out of this municipal pool, and eventually it grew over time, and about 17 homes were lost, and people had to leave this area. So sinkholes, carbonate topography, it's something to be aware of. And so just to finish off here, Karst topography occurs predominantly in limestone bedrock, although it could occur in marble and in dolomite or dolostone. Too much pumping lowers the water table, causing land surface to subside or saltwater intrusion. Due to population growth and drought, loss of groundwater can have severe impacts in society, because it's a really important natural resource of fresh water to all of us.